Scaling, I think is the title. I'll be your moderator. I'm Jimmy Song. Let me just hand it off to you guys to just very quickly, like 20-second intro of yourself, so we can get started. But yeah, yeah.
I'm Peter Todd. I'm a Pledge Cryptography consultant, and used to go work on Bitcoin Core, but these days I just play Bitcoin Core dev on TV.
My name is Jack Mallers. I play a lot with Lightning. I started Zap, but probably the most unqualified on this panel. This is a star-studded panel. Pretty humbled to be up here.
Well, at least you're writing code. So actually, I mean, I can code, and I have coded in the past, but mostly I figured the highest value thing for me to do in terms of use of time is applied crypto protocols. So that's what I tend to focus on.
But Cypherpunk's code. Anyway.
Protocols are like a high-level form of code.
Cypherpunks also sometimes prevent code from being written if it's really bad code.
All right. So the question for me to start to kick off the panel is, we got two things that I think a lot of people are thinking about with respect to development. How important are scaling and privacy, especially with respect to each other? And I'd like Peter to go first.
I mean, it's kind of hard to have scaling without privacy. You know, I mean, if in a decentralized environment, like the reason why you don't get privacy is because all the data winds up in one place and everyone has a copy of it. And the moment you go scale that, if it's a decentralized system, fundamentally less data has to be published. And the only, result of, that can't not result in privacy, at least with respect to some threat model. Some people go quibble and say, well, I mean, this guy is still getting chain analysis run Lightning nodes, et cetera, but that's still, with respect to some threat model, that's still better privacy, in much the same way as that a PayPal transaction is still better privacy than Bitcoin in some respects. It depends on what your threat model is. If I'm in cahoots with the U.S. government, I don't care that they probably have a copy of every single PayPal transaction.
Yeah, I think scaling and privacy are pretty correlated when it comes to Bitcoin. They're not perfect, but for privacy, if you're not shouting as much to the whole world about what you're doing, you're also probably scaling at the same time. So you kind of see that with Lightning. Like Lightning was a TPS enhancement originally, and some privacy benefits came along with it. So as far as priorities between the two, that's probably just a personal take, the eye of the beholder, in my opinion.
Yeah, I mean, I think the layer 2s that reduce the bandwidth requirements are obviously much better for computer science scalability. Some people misuse brute force scale and think that means scalability, i.e. huge block sizes, but that tends to not really have an effect on privacy, but have an effect on the survivability and decentralization and censorship resistance of the system. I mean, I agree on the Lightning side. There's another direction, which is a kind of counter example, is the confidential transactions. So they're about 10 times bigger, but they improve some parts of privacy, right, including the value involved in the transaction. So that's an example where some privacy is more expensive.
Yeah, so Adam, your company Blockstream is doing Liquid, which is a sidechain. Jack, you're doing Lightning, which is essentially a second layer. They're both second layer technologies. I'd like for you guys to make your case for why one is better than the other. And I want to start with Adam first.
So I think I can fairly say why not both, because actually Blockstream also has a Lightning implementation called C Lightning, and Christian Decker put some time in to ensure that C Lightning can work on top of Liquid and on top of Bitcoin. So now you can, move Bitcoin on top of Liquid using Lightning. So it makes, people talk about layer 2, but it means that Liquid is kind of a layer 1 because the layer 2 Liquid is a layer 1.5 because it itself is a layer on top of Bitcoin, and yet Lightning also works on top of it. So you kind of draw the analogy that Liquid is fits in between and is kind of a layer 1.5. Potentially you could, transact other kinds of assets in C Lightning on top of Liquid. Like you could have a tether, US dollar tether, Lightning at high scale, or you could move Bitcoin from the Bitcoin chain to the to the Liquid chain very quickly by using a Lightning swap between two channels with different asset types on them.
Jack, do you want to make the
I
case
can't
for it?
believe I love you and all your work. I can't believe I'm on a panel having to disagree with Adam.
Believe it.
I believe it. It's happening. I think that the biggest difference is probably the trade-offs, which you've probably seen threads on Twitter of people arguing about this, is that Liquid comes packaged with a more trusted trade-off than Lightning. I wouldn't call it centralized by any means, but it's certainly more trusted. And it also doesn't inherently solve things like transaction throughput. There are still limits, and confidential transactions are great, but they're huge. So them leveraging Lightning on top of it is super interesting, but I think by nature, Lightning's killer app is instant transactions, I would say. And even with Liquid with faster block times, it still can't perform in ways that Lightning can with instant transactions. So that would be my summary, but I'm a fan of both.
Peter,
your thoughts on both of these technologies and what you find more compelling?
Liquid is centralized, end of story. And I mean, in its fundamental architecture, because it's taking a copy of Bitcoin, which is trusted and works and likely work, and then swapping out the consensus system means that it is also not particularly scalable. You know, if Liquid is going to grow to very large numbers of transactions per second, it's going to have to be radically changed. On the other hand, I mean, you can't really blame that engineering decision because it means you get trusted code that actually works and get into production quickly and see if the service is even worthwhile. You know, it's kind of like AI companies where the first product is actually a bunch of people in a back room going and doing what the AI would, just see if it's even worthwhile. You know, and Liquid isn't quite that bad. You know, it's not quite that bad of an example, but it's certainly not, in its present form, something that's scalable. On the other hand, the math of it, the confidential transactions, you know, that's very real, and that's a very big innovation. And it's interesting to see, of course, how Monero picks it up. So I wouldn't, you know, think to answer the question, I don't even really put them into the same category.
Adam, you have any response to what Peter
Yeah, I mean, I think that the layer 2s are basically forced to make security trade-offs. And if you think about it, that's inherent because if you could get a free lunch, you could get the same security, then Bitcoin would probably already do that, right? So, you know, Lightning is making trade-offs because you've got this reactive security model, you've got more hot wallet risk, and then you've got channel capacity constraints, where Liquid is making a trade-off that is clearly more centralized than doing things on the main chain, and you're always going to get better censorship resistance and better security for cold storage on the main chain. But what Liquid does fit between is it's clearly more decentralized than giving custody to a single exchange. So if you are exchange trading, I think there's a reasonable argument to say the Bitcoin chain doesn't need to know or care that you're moving Bitcoins from one exchange to another. Liquid can do that for you. And if you look at the periods where there are, you know, mass trading on Bitcoin during a price run-up, the fee spikes are caused by the traders. So if they would take their trading into Liquid, I think they don't really lose much by doing that if they're doing cross-exchange activity. When they finish, they can cold store it back into Bitcoin. So yeah, I think it's they're just making different trade-offs. Now, C Lightning on top of Liquid, you know, you could say that it's not as trustless as Lightning directly on Bitcoin, but on the other hand, Lightning directly on Bitcoin already has a reactive security model, and I think people are generally not recommending you do huge values on it because it's hard to transact. So maybe, you know, Lightning on top of Liquid is not so far removed from Lightning on top of Bitcoin from the perspective that maybe you shouldn't put your life savings in a hot wallet on Lightning either, right?
I mean, Lightning over Liquid does open up some interesting possibilities where, you know, potentially you could like reserve block space for retaliation transactions or, you know, justice transactions and so on. So there's a bunch of curious trade-offs you could go make that don't really, you know, you can't really do them on Bitcoin.
Now I play devil's advocate. Yeah. So what do you think? Now I'm enjoying my argue with Adam role. I'm living it now. So what do you think about just Lightning within itself without Liquid at all for some trading use cases? Because a lot of the issues that you brought up, like reliance on penalty transactions and channel capacity, these are all solvable things, which, you know, in due time. But even something like L2 is a huge enhancement. So in theory, like, why not just open some private channels between a proprietary trading firm and an exchange where I don't have the reliance on the Liquid like consortium and a lot of the inherent downsides that Liquid brings?
So I think, I think point to point you can make it work between two parties, but as soon as you expand it to, thousands or tens of thousands or millions of users of an exchange, you have a kind of cash miss problem, right? So if an exchange has, I don't know, 1 million users and $100 million of funds, they can only afford to put $100 worth of Bitcoin in each channel. And you don't know, like some random user is going to deposit $10,000 and expect to do a withdrawal immediately. You're going to miss the channel. So I suspect that for the exchange use case, unless you're really good at predicting who's going to randomly buy Bitcoin and insist on immediate withdrawal, it's going to make things worse because you have so many cash misses. And I think the other thing about Lightning is it's only really able to make faster. I mean, each Lightning transaction is a valid Bitcoin transaction or a valid transaction of the chain beneath it. So it can't offer you a feature that doesn't exist on the chain. So Liquid adds more asset types like US dollars and things like that.
I agree, but then I would revert back to Peter's point in considering that they're just not even comparable, in my opinion, as like competing solutions. They just target entirely different things, in my opinion.
And I think from a tech perspective, we can definitely do better ways of transferring other types of assets that are secure with similar properties as Liquid with different architectures. I mean, I'm working on one myself, and other people are working on another one called RGB, which is closely related. So there's definitely a lot of stuff to experiment with. But again, I mean, I think ultimately the architecture of Liquid came about a need to go do something that actually worked in production in a relatively short period of time. So I'm not really surprised to go see that. And they can go change that too.
Yeah, I mean, last point on assets. So I think sidechains have an inherent security trade-off. There's no currently available technology to improve on it greatly. But for the issued assets on a sidechain, they are surprisingly bearer because the user can run a full node, and if the block signers were to misbehave significantly, the users still have all the data and can fire the block signers or replace them. So that means that, assets often have a custody risk anyway, but or like a company management risk if they are shares in a company. But apart from that, in terms of the seizability or freezability of the assets by block signers, I think you can overwrite that because you have the ledger and you can replace them.
Well, so there are clearly some trade-offs in both systems, and I think you get more privacy through confidential transactions on something like Liquid, but you absolutely get a lot of scaling on something like Lightning. And those are both fairly difficult, right? Like the whole Lightning implementation, bolts, and like all the different tech that goes in, Liquid and confidential transactions, all of those things are enormously difficult. We haven't figured out a way to do like a trustless sidechain, for example, yet. And Adam, you've been talking about that since like 2013. So it's been like 7 years of exploring this. The question for you guys is, how do we make sure that this technology that's very complicated, like, is at the sort of at the same level of rigor that a lot of the other stuff in Bitcoin currently is, and make sure that they don't have some critical security vulnerabilities? Peter, you can start.
I mean, unfortunately, I think there's no easy answer there other than throw money at developers who know how to go audit code. And that's not a very good answer either because well, I mean, one of the problems with audits, of course, is it's very tough to know that anything was actually done. When I go do audits of source code, often the way I approach it is I will literally take a chunk of source code and walk through commenting line by line by line as what exactly is this doing? What did it mean? How did it interact with other things? Because even just for myself, I mean, you kind of have to do that to keep yourself honest and keep yourself focused and actually looking for these issues. And that's only one of many things that get done. I mean, Gregor Maxwell, as an example, he likes to go through code and verify that his understanding of it works and the tests work by deliberately breaking it over and over again. Changing one line to do something different and seeing, hey, do the test still run? And all this stuff, it's really alien, I think, to normal development practices. And normal development practices don't create secure code. And this is just a very big challenge, and I don't have good answers for it.
I agree, unfortunately. I think inherently it's a really difficult problem when it comes to Bitcoin. At the end of the day, incentives are king. Incentives are king, money rules. And the most profitable business model in Bitcoin to date is owning the asset. And it isn't necessarily logical that the profits that you make from owning Bitcoin should be redistributed in paying developers. Like sometimes there's a real problem in that the demand for this asset, the use cases it delivers, and the people it attracts sometimes far outpace development resources and current engineers. And the reason that an engineer may graduate from a high-class school like Stanford and go work at Google instead of become a Bitcoin engineer is just pure incentives. It's because they wouldn't be able to pay rent otherwise. So I think inherently it's been a tough problem. It's getting much better, but there's no perfect answer to date that I'm aware of.
Yeah, so I mean, Blockstream has extended Bitcoin with Liquid on Elements is the open source platform that people use to make other related chains. And so we have a lot of high assurance code that we have to make sure it's secure. And similar for the Blockstream Green wallet, we also take that seriously. So the approach that people use is, for example, much higher cross-checking. So one person can't check in code without at least one or two other people, depending on how sensitive it is, checking every line of code and not allowing it to go through unless that's happened. Now, that's not something that average developers are used to dealing with, so it could be frustrating, but it helps provide, some second set of eyes looking at it and looking at it carefully. And I think the other thing is, for some of the cryptography stuff, it's also very important it be correct. And the libsecp library and the libsecp ZKP extensions, which have confidential transactions and a few things in it, some of that stuff has formal proofs about its correctness and significant fuzz testing. On the Bitcoin side, libsecp, with fuzz testing, they found actual defects in the OpenSSL library that had been there for, like half a decade, and nobody'd found them. So it shows that Bitcoin is doing some cutting-edge testing, and some people have put a lot of effort into that. So, but nothing is perfect. I mean, the other thing we did in Blockstream is contract external security audit company. And I take Peter's point about, people will take your money, and these things are not cheap, right? And did they actually do the test? And I think we have reasonable confidence that they did useful things, because they asked lots of in-depth questions that showed they understood, and they found, minor things like, I'd be better if you did this or something like that. So they'd clearly gone through it and understood it. They seem to enjoy learning about Bitcoin, but they were kind of a good company with applied crypto expertise. But yeah, it's
Can you say which one?
I'm not sure if we're supposed to, so I have to check that.
Don't know if you're under NDA.
Quite often, there's a different price if you're gonna, publish it. So I have to check.
Okay, good to know. All right, so let's switch gears for a moment. What are you most excited about with Taproot, and how will that change whatever business you're running or whatever it is that you're currently working on?
Taproot on its own or Schnorr Taproot?
Well, Schnorr Taproot, SegWit V1, basically.
Yeah, I think, I personally have a bias towards Schnorr. I think that it has a more direct effect on Lightning and a lot of the stuff I'm working on. But again, I think that privacy and scalability sometimes have this direct correlation when you talk about Bitcoin upgrades, and that we see this all the time. And you see this with Schnorr as well. And that signature aggregation certainly enhances privacy a ton, and it also makes the base chain much more scalable. And so I think I'm most excited about Schnorr personally. How it will directly affect my business probably won't. We don't do any crazy amounts of exchange volume or anything like that. But it'll be good for Bitcoin, which is good for me.
Yeah, Blockstream's going to use those things in lots of different places. So the Green wallet is multisig based. So we'd be interested to switch its multisig to Schnorr, because that will make them smaller and indistinguishable from single sig. And that applies to both 2 of 2 and 2 of 3 configuration options. There's a way to generate 3 keys that results in a single public key. And also there are like branches in there. There's a CSV clause which is used to access your funds if you lost your 2-factor authentication device. So that could be a Taproot OR branch, so that could be actually hidden as well, which is nice. And then on Liquid, there's a peg, right? You're moving Bitcoins into a peg, and the peg is a big multisig, and it has an OR branch in it as well. So as today, an 11 of 15 multisig, which is kind of big. That could become much smaller with Schnorr. And then there's an OR clause with a time lock that has a 2 of 3 with offline keys as like disaster planning in case people have lots of backup failures and IT hardware failures and things, that the funds wouldn't be trapped. So that could also be hidden in a multisig. Now, of course, these transactions will be recognized because they're being spent all the time, but it's still interesting and saves a lot of space.
Do you have any thoughts on payment points, like PTLCs as opposed to HTLCs when it comes to Lightning? Like, has any of the C Lightning team thought about that at all?
I don't know the details, but you probably know more, but the L2 versus L3 discussions, I can't elaborate on that.
Sure, fair enough.
So I'll give my sort of somewhat downer answer, which is for the stuff I'm actually working on personally, Taproot and Schnorr are totally irrelevant because the protocols I've tried to design, like OpenTimestamp as an example, and the proof marshal work I've done, doesn't require anything out of Bitcoin. I've always kind of taken the viewpoint, well, ideally, I should create protocols that just use Bitcoin as a cryptographic primitive, like a publication layer, commitment layer, timestamping, where it would be very difficult for Bitcoin miners to even stop me from using it, let alone from me needing new features. And so far that approach has worked very well. On the other hand, the stuff I go work on is not payments.
Can I ask a question, hijack this a little bit?
A little bit.
Okay, so when we think about SegWit, which was like trivially like a fairly safe upgrade that everyone should have agreed upon, there was a lot of contention. And I feel similarly about Schnorr Taproot in the sense that there's so much general consensus so far. I haven't heard a bad word, that it just feels too good to be true. So I'm kind of curious everyone's opinion on if there were to be someone to disagree, throw a fit, fork Bitcoin, who is that actor in your opinion?
Well, so I would point out, like, Schnorr is interesting where in the academic community, I've seen a lot of people criticizing sort of Bitcoin in general, saying, oh, well, why didn't you do Schnorr? Like, why is this taking so long, et cetera, et cetera. But something a lot of people don't realize is that in the process of implementing Schnorr for real, little details about Schnorr were discovered, and it turns out many of the implementations that people would have naively made are not actually secure for kind of deep cryptographic reasons. So yeah, I guess I do kind of share your concern. They're saying, well, I know maybe there is something that we've missed, because it looks like academia missed some of these issues because nobody had actually bothered implementing this so-called trivial thing.
Yeah, I mean, a number of people at Blockstream and outside Blockstream have been working on the details of how you set up the keys and prevent related key attacks, basically. There's a risk that if you do it naively, that you generate your key and I say, hey Peter, I want you to co-sign with me, and you make a key that can sign the whole thing because it like subtracts my key out of it, basically. So to prevent that is non-trivial. It turns out it's been through 2 variants that got broken. One by Greg Maxwell and myself. We broke the first one, and then Gregory Nevin and team, let's get some academics, broke the second one. But the third one looks very good.
And to be clear, like that multi-sig example is exactly what academics would have been criticizing Bitcoin for. Well, why don't you do this? Because this becomes trivial. Turns out it's not.
Yeah, the entire Taproot thing with Schnorr and everything else, it's Bitcoin's actually bringing cryptography into the real world, which I think is really cool. So related to some of the privacy and scaling issues, let's now start looking into the future. What sort of features that we've been talking for a long time about would you like to see happen? And I'll include some things that on the main chain. So probably a pretty controversial one on this panel would be confidential transactions. Another one would be cross-input signature aggregation. I think, Adam, you can talk about simplicity maybe, or some sort of trustless sidechain or something like that. What would you like to see happen, and what would be our argument for getting it into the base layer of Bitcoin?
So I like all of those things. So, I mean, confidential transactions has, I think the two main concerns, and there is hope that some of these things can improve in terms of optimization. So one is they're big, so that's a concern. So bullet proofs makes them considerably smaller, but still. So I think that may be about enough to make it viable from a size perspective. But unfortunately, bullet proofs are not post-quantum secure. So there are two variants of confidential transactions. One that if, with a supercomputer very far in the future, you can break privacy, but you can't inflate, and another one where you can't break privacy, but you can inflate. And so bulletproofs are the type where you can inflate. So the thing that's more attractive from a size perspective is not so attractive from the security, very long
Monetary policy.
Yeah, security. So, there may be some prospect to further optimize the post-quantum secure version, the algo-mal commitment. So that might be something that brings it forward. But in any case, on Liquid, we did the one that is not post-quantum secure, because Liquid is not for like super long-term storage. I think that's something people care about if they want to park Bitcoin for years, decades or something. On Liquid, you would be trading and then putting it back on the chain. So it's Liquid. You asked lots of questions though, right?
Well, I mean, just what would you like to see, right? Like among the technologies that we've been talking about, like say post Taproot.
I mean, simplicity is an interesting one. That would be an interesting discussion to have. So, we have Bitcoin branch with simplicity integrated, actually. And simplicity is a generic way to extend Bitcoin. It's a new script version, a new scripting language for Bitcoin. It's very low level, and it's formal proof friendly, so you can prove things about it formally. But as an example, if simplicity were in Bitcoin today, we wouldn't have to have a soft fork for Taproot and Schnorr. You could just implement them. And simplicity scripts are extremely compact, so it would be practical to do so. And it also changes dynamics so that you can implement things in native C and formally prove their equivalence to the simplicity version, and then soft fork that to speed it up if it's a large program. So it brings a new prospect that this kind of upgrade would be optional. It just makes your machine, it means you can process transactions with lower latency. So if you don't have a low latency requirement to verify scripts, or you have a fast machine, you could delay upgrading because you can verify the simplicity version.
Though to be clear, I mean, it's not actually just like in that example, because the nature of Bitcoin is a consensus system. It's not just a speed increase; it's also a size increase. It's essentially, I mean, when you say you'd be able to not have a soft fork to implement Taproot, of course, it does mean you get this massive simplicity script, which is a lot smaller than you'd expect, but it's still much bigger than you'd actually use as a practical transaction often.
So, I mean, I'll give you an example of the data size. So, Russell O'Connor implemented, from scratch, from bits, 32-bit adders, a big number library, elliptic curve library, and a SHA-256 library, all within, I think, 15 kilobytes or something like that, which is surprisingly small, but still not something you want to attach to every transaction, for example, right? So that's where the jets come in, that you make common libraries. And that could apply to simplicity scripts too. You could have a special type of UTXO that contains a script that you want to reuse. So that would be a way to reduce size.
I mean, you can kind of think of jets, it's really just a fancy term for a special purpose opcode. I mean, in Bitcoin script, if you really stripped it down, you could, in theory, implement anything you wanted from the primitives in Bitcoin script, but it just requires so many opcodes, so many instructions, it's totally
I mean,
impractical.
you go past the opcode limit very quickly. Yeah.
So, I mean, I think that the interesting question for people is, because it's generic extensibility, do people want that amount of power? So it has a formal proof about that you can make lots of formal proofs about predicates, things you state about your software that you can't easily do in other languages typically. And, the other phenomena we see is that in layer 2 protocols or applications that use Bitcoin script, I think the thinking may be a little bit constrained by what opcodes do we have, or what small opcode addition could we do to arrive at a protocol, whereas simplicity would give you a much wider open field, right? You've got introspection, you can write covenants, you can build new primitives from the ground up. So maybe given like a wide open field, people would find even more interesting Lightning variants or other layer 2 variants and be able to do them immediately without waiting for opcodes to enable them.
Granted, I mean, Ethereum has that property where you can do all this crazy stuff with very little work. And I mean, I think that's a big part why like academia likes it, as well, of course, academia paying a lot of Ethereum developers. But I don't really see what's coming out of that as being that much more interesting than what's coming out of Bitcoin. And I think, I mean, I'm kind of a bit biased there because what's coming out of the Ethereum side, hasn't proved to be reliable. You know, the software engineering is so much harder. But it may be the case that we don't actually need a lot of this stuff to do interesting things. You know, and I mean, to kind of answer your initial question, my answer would probably be, I mean, I'd be happy if Bitcoin protocol never actually changed. You know, I wouldn't be super happy about it. I'd like to see other stuff, but it may be enough to just leave it as it is, and we'd be all right.
Jack, you got any insight?
I'm more on the Peter side. My answer would be something much more trivial, like sig hash no input or something like that. As far as confidential transaction goes, I don't necessarily see the size being a huge issue. I'm much more concerned about the monetary policy. That is very scary to me. Whereas, I don't know, transaction sizes are an inherent property of Bitcoin. They're allowed. So I don't know. But yeah, I kind of agree with Peter.
You know, when we say monetary policy, I just point out, like, maybe that's kind of the wrong word to use. It's sort of a security thing in general. You know, and I think there's the same issue, too, with simplicity, where the failure modes become so much harder to debug. And in the case of privacy tech, it's really hard to detect a failure. You know, nobody to this day knows whether or not the Zcash monetary supply is what they claim it is. Because they've already had 2 inflation bugs, maybe there's a third. I mean, you just wouldn't know until it happens. And that's a very, very big issue. And unfortunately, I would also point out, like, Bitcoin itself, it's hard to imagine Bitcoin existing 10 years prior to when it was created. Certainly hard, like, say, 15 years prior, because cryptography just hadn't gotten to the point where it was trustworthy. You know, we did not have hash functions that have withstood the test of time in 1999. And unfortunately, that may prove to be the case with confidential transaction stuff. And we're not. It'll take a while for us to know. On the other hand, if it's on Liquid, so what? It's it's a blockchain
Right.
problem.
Well, I mean, it's about complexity, and so there's a general kind of complexity risk. So Bitcoin itself had a narrowly missed inflation bug fairly recently, which kind of crept in across 2 changes where some semantic changes crept in that people kind of forgot when they got the second version. It was noticed without being exploited, but that shows you that software complexity is enemy of security.
But in that case, that bug would have been noticed had it been exploited. Like, I think that's the fundamental difference.
It would have been noticed. This is true. So then the other thing to say about the software complexity is that I think people are more inclined to trust things that they understand. And so it's very easy to understand that you can add up the values of the inputs to a transaction and check you can do it with pen and paper if you can inspect the data. Whereas if it's a confidential transaction, in principle, it's actually the same thing, because adding up 2 Pedersen commitments is not that hard if you understand elliptic curves. So less people understand elliptic curves, but it's still an addition operator, and that's all you're relying on. So you're relying on the range proof. Also, the range proof is just doing iterated OR proofs that bits are equal. So it's but that's still because it's more complicated and requires more understanding of applied crypto. You can't, unless you understand it, you can't verify it for yourself, where you can verify the more basic thing. So, there's scope to make mistakes in Bitcoin, because Bitcoin almost had an inflation bug, as Peter says. It would have got noticed really fast.
There are many different implementations of what is the monetary supply of Bitcoin at this moment. Probably less than we'd like, but like, anyone can go write that implementation with very, very little work. It's just a normal add.
Out of all the UTXOs at any given moment should just add to, plus whatever future rewards there are, it should be less than 21 million. But yeah, it isn't very difficult. So if we could get confidential transactions, right, like onto Bitcoin, is that something that you would support? I think, Adam, you pretty much said you would. Like, what sort of things would you look for in order to accept something like that on the network?
I mean, I think people argue on both sides of which version is better. personally, I would go for the privacy breaks, but the supply isn't broken. If you get a quantum supercomputer many decades in the future, I think that's a preferable failure mode, because loss of the supply is it's largely the end of the coin, which is more important.
I mean, it's hard to go put a price on privacy in a lot of situations. So I'd go the other way, but also I'd say, no, I would not support putting confidential transactions on Bitcoin itself at this time. I'd give it, another 5-10 years.
I also probably wouldn't support today, but as far as the former or the latter, for which form, I think I agree with Adam wholeheartedly. That a supply bug and monetary policy issue with Bitcoin would be the death of the coin, in my opinion. At least for me personally, I would stop using it as a store of value, obviously, especially if I didn't have the luxury of realizing a break in the investment vehicle that I'm using to store my money. So I think there's a right answer there, in my opinion.
So I think there also could be a middle ground, which is to make an extension block so that the inflation, like I'd say it's mostly a complexity risk if you were to use the Algorithmal commitments, that there's a bug in the implementation despite best attempts. So if it was in an extension block, then the extension block could blow up without affecting the main chain. And extension blocks are consensus compatible, and you can apply the overall same block size or block weight limits to it. So that might be another option. And it's the same kind of story for simplicity too, right? If something is interesting, has relatively solid security arguments and proofs, but you're worried about the complexity risk, you can put it in like a security boundary, opt-in security boundary. Sidechains are a bit of a weaker form, but extension blocks are actually pretty good.
Yeah, it's extension blocks seem like, at least the way you presented it, seems like a sidechain without any of the trusted back and forth. But you essentially have the same problem, though, right? Like getting coins from in the main part of the transaction to the extension block and back, and coming back is where it gets really tricky.
But I mean, an extension block that is part of the rules and thus part of the block size, you can apply whatever rules you want. I mean, another way to go say it is that all transactions, in a way, their history going backwards is an extension block from the point of view of auditing. Anyone can go and audit how much money moved in note, which also then conversely means that an extension block, if you don't put a limit on how many coins can end up in there, you may actually find that you still destroy the rest of Bitcoin because so many coins get stolen, it crashes markets. So there's not simple answers there. And, frankly, I mean, Liquid potentially has that same issue, as does any big holder. It's just not, not at this point an issue because there's just nowhere near enough money on Liquid to matter in that case.
Yeah, you could see the in a future where Liquid has a lot more liquidity in it, because if you look at the amount of Bitcoin in exchanges, it's pretty severe. There are individual exchanges with arguably 1 million Bitcoins, for example, and that's a big risk. So Liquid could have the same problem potentially.
All right, good stuff. All right, we have about 6 minutes left. I'd like to open the floor for questions before before this next question. So we talked a little bit about sidechains. Is that really dead at this point, or what do you like besides elements? I think a trustless sidechain is something that we've been talking about, like I said, from 2013. What are your perspectives on the future of sidechains at the moment?
Yeah, I mean, I think it would be attractive to have a fully peer-to-peer sidechain, but there are at least a couple of technical hurdles to achieving that. One is the degree of mining centralization. So I think that's improved a little bit in the last few years. But leading up to the fork drama, there seem to be attempts to use relatively centralized control from one particular manufacturer to influence a lot of things, and that's receded and self-corrected a bit. I mean, there's still like moderate centralization in pools and mining, things like that. So that would mean that in Liquid, the federation of HSMs that runs, implements the automated peg, it has some centralization. If you were to do it peer-to-peer, random miners would have control of the peg, probably without HSMs, and could spend the coins arbitrarily, right? It's not an extension block, so nobody's able to check that.
I mean, I think the answer is very simple. It's that no one has shown a sidechain design that's decentralized and works. They just don't exist yet. Maybe in the future they will, but until someone shows that, it doesn't exist.
Right. So there's definitely a open R&D problem of how to elevate the security. I think the only kind of prospect at the moment is, a few more generations of efficiency and scalability of things like bulletproofs. So zero knowledge proofs, so that you could prove that the blockchain validation code ran on the extension block or sidechain without needing to, actually see it all or evaluate it all. And I mean, the tech is evolving very fast, and there's a lot of innovation in it, but it may take years for that kind of tech to become available.
Keep in mind, like, even that kind of stuff still has issues around seizure of coins. Because miners can still go and force essentially a reorg to go say that, well, we're not going to allow these coins to leave, even though there are valid ZK proofs there.
All right, good stuff. Let's get some questions from the audience. We got our first question over here.
Yeah, I'm a Bitcoin developer layman, so you guys are way beyond me. So I have a very simple question that I've been asking for a year, and I hope that maybe at this conference I can get it through my head. And that is, why is Lightning necessary? I'm not saying it's not an improvement, but one thing that Jimmy Song has taught me is that anything that can be done in a centralized manner can be done better and more efficiently. And so that's, to me, it seems to me like Bitcoin is just, the Lightning Network is you're just developing a second standard. So please explain to me, is Lightning Network really necessary, or are we going to do this off-chain?
I'm trying to decipher where the actual question in there is, because you quoted Jimmy in saying that a centralized service could potentially do something better. Did I hear that right?
Or just faster and more efficiently.
Yeah, that argument still stands and likely will forever. So I don't think Lightning is necessarily competing with a centralized service. It's not centralized by design. That's why, in my opinion, it's been in years of development and will be still for a much longer time. But is it necessary fundamentally? Yes. In order to increase the throughput of the network, the TPS metric, whatever transaction per unit metric you like, yes, that Bitcoin at the base layer has inherent limitations just by design. Global consensus is a really hard thing to solve for and is generally inefficient. And so, yes, my binary answer to your question is yes, it certainly is requirement.
And I think you mentioned it before, but like, Lightning is already a much better user experience than normal Bitcoin transactions. I get my Lightning wallet out, I go point at the QR code, I hit go, and the payment's done. And it takes like seconds, if not less, versus waiting around for 10 minutes or more.
Yeah, like for practical uses of Bitcoin, instant transactions and having a sense of finality within seconds is a massive killer app, quote unquote. Where, even if something like fees were theoretically solved with Bitcoin, waiting 10 minutes for finality with money in traditional commerce is just a non-starter. So instant transactions, just that pure use case alone, whether you scale that to traders, whether you scale that to online commerce, whether you scale that to remittance, it is a killer app within itself. Bitcoin is the only natively digital asset of all time. So you're actually physically clearing and settling and gathering finality with an asset natively for the first time in history with any money. And so that's a characteristic that we've never seen before. So if money is like a technology, that's a huge invention for money itself.
Yeah, so I would say it depends on necessary for what. Necessary for Bitcoin to succeed. To a degree, Bitcoin's already succeeded, and what had succeeded before Lightning was a thing. Necessary for helping more people to adopt Bitcoin, possibly, but that's true of a lot of other things too. So it really depends on what context you mean by it. My inclination is to say, no, it's not necessary for its properties as store value. A lot of people used it that way before Lightning came, and a lot of people will continue to use it without any Lightning. There are other ways in which Lightning enables new use cases, but like any invention or technology, whenever you have something new, it enables new use cases, and for that, it's a nice thing to have. So I would say it's necessary for the new use cases that we haven't really thought of yet.
Very good. Regarding SegWit version 1, I want to know more about the approach that we should take to soft fork the improvement. And specifically, I want to know and let me know if any of this has changed because it's SegWit v1 as opposed to SegWit v0, but should we allow the miners to signal? If so, what should the threshold be, and how long should we give them until we do a user-activated soft fork?
Yeah, so this is a discussion from the Bitcoin Dev mailing list, which was the previous soft fork, SegWit v0, went through, was initially done as a BIP9, which required 95% of miners to signal that they're ready before it would activate in a 2-week period. Of course, a lot of different things happened, and we had UASF and the New York agreement, and then that ended up with 80% being, sort of forced in via BIP 91, and then that eventually led to 100% of miners basically saying that they're ready by, middle of August, basically, and it got activated that way. There's been a really interesting discussion on Bitcoin Dev mailing list with regard to how should we activate the next one. So I'd love to hear your guys' thoughts on what you think the actual threshold should be and what the methodology should be. And are we going to go to BIP 8? Are we going to do BIP 9? What are we going to do?
I'll just explain what BIP 8 and BIP 9 is. So BIP 9 is that there's a period for miners to signal. If they don't signal, that's the end. It doesn't get activated. Where BIP 8, after the signaling period, if it doesn't activate, it activates anyway on the end date.
Yeah, the default is the difference between those two.
So, and I guess BIP 8 was proposed as a kind of, okay, let's not experience the BIP 9 drama next time. So if it's a long period of time, maybe it's okay. The other thing I was thinking is that you could, SegWit had, was combined with a effective capacity increase, or effectively a block size increase. Blocks today are, between 1.5 and 2.5 megabytes or something like that. So that was more controversial trade-off, right? Some people wanted smaller blocks, some people were okay, some people wanted even bigger ones. So, but Schnorr is like pretty much, a better signature algorithm, plus or minus the conversation we had earlier. So I think there's less room to debate. But another problem I would say with the UASF is that it was so last minute and rushed that it created its own failure risk, but it was done at a point where the alternative was even worse. So the last minute stuff was the dangerous stuff. So I think, what you could do this time around, as we have the benefit of hindsight, is make, let's say, a BIP 9 and have a well-tested UASF ready to go if things get silly. So that it would be more planned. I think it's the unplanned last-minute code changes that are super dangerous. It doesn't have, normally there are months of like code testing and test networks. That thing was written in like a very short period of time, right? It did the job and it averted a worse outcome. But
I think it's important to recognize when you go say, like with BIP 9, the default is for it to activate. BIP 8, the default is activate. When you say activate, what you're really saying is on the nodes of people who run the software. BIP 8 has no mechanism to actually get consensus over the network, whereas BIP 9 has a mechanism where either it does get consensus through the mechanism of soft fork, or nothing happens. Unfortunately, I kind of have to say that I think from a sort of first order safety engineering perspective, miner signaling is far safer. BIP 9 is far safer than BIP 8. Unfortunately, we can't just look at it from that simple perspective. We also got to look at it from the second order perspective of, well, what's the politics around this? What does this say about miners being in control and so on? And I think with SegWit, with the UASF, it certainly shows there can be circumstances where you're better off forcing the hand. And I think that was a case where miners blinked and realized, well, we might go lose this illusion of control. and we can kind of save FaceBit by then activating. But honestly, if that hadn't gone that way, I don't know what would have happened. I don't know. Anyone really knows. And maybe, like Adam Beck says, the next time making sure you have two things available and it actually work might be the lowest risk. But I mean, none of this stuff is going to be low risk.
Yeah, we're charting into sort of crazy unknown territory, which is what makes it both exciting and scary. Anyway, I want to thank my panelists for their wonderful contributions to this panel, and hopefully that helped you.
All right, that was excellent, Jimmy. Thank you so much. Oh, just like leave them.